This instructional video will help you understand standard deviation and its properties, conceptualize the standard normal distribution, and then use the empirical rule to estimate probability of.
Carl Gauss defined mathematical distribution in 1833 in order to describe the error in predicting the orbit.
The area under the curve within a certain interval corresponds to the probability of the normal random variable in that same interval. The standard deviation is always non-negative. It is zero only if all of the data values are exactly the same. The standard deviation can increase dramatically if there are one or more outliers in the data. The empirical rule can be used on a symmetrical bell-shaped data set to estimate the probability of an event occurring. Approximately 68% of the data lies within one standard deviation of the mean. Since the distribution is symmetrical, 34% of the data lie within one standard deviation below the mean, and 34% lie within one standard deviation above the mean. Approximately rule to estimate probability. Suppose that grade point averages of undergraduate students at one university have a bell-shaped distribution with a mean of 2.61 and a standard deviation of 0.4. Using the empirical rule, what percentage of the students have grade point averages that are between 1.81 and 3.41? We begin by sketching our curve and labeling our mean of 2.61. And then I add the standard deviation of 0.4 to that 2.61 to get 3.01. And I add the 0.4 again to get 3.41. And that's where I can stop because that's the upper boundary that I'm looking for. And now I take 2.61 and subtract 0.4, and I obtain 2.21. And I subtract it again to get 1.81. Again, I can stop because now I've found the lower boundary. As you can see, I have gone out 2 standard deviations above the mean in order to get to 3.41, and gone 2 standard deviations below the mean in order to get 1.81. And if you'll recall, about 95% of the data should lie within 2 standard deviations of the mean. Therefore, the answer to what percentage of the students have grade point averages that are between 1.81 and 3. Another example using the empirical rule to estimate a probability. Suppose that grade point averages of undergraduate students at one university have a bell-shaped distribution with a mean of 2.57 and a standard deviation of 0.44. Using the empirical rule, what percentage of the students have grade point averages that are greater than 3.89? Please do not round your answer. So again, we will construct our bell-shaped curve. Our mean here is 2.57. And I'm looking at what percentage of GPAs are greater than 3.89. So I only need to add the standard deviation until I get to the value of 3.89. So 2.57 plus 0.44 gives me 3.01. Adding 0.44 again gives me 3.45. And adding it again gives me the 3.89. So I'm looking for the percentage of data that is in this area here. This is 1, 2, 3 standard deviations above the mean. So I'm looking for the percentage of data that is greater than 3 standard deviations above the mean. And I have my breakdown here, and the percentage of that data that is three standard deviations above the mean is 0.15.